Today I will talk about principal component analysis. It is part of my series of lectures on machine learning. This is my lecture outline. First I will give introduction, then I'll talk about mathematics of principal component analysis. Then I'll talk about assumptions and limitations of principal component analysis. Then I'll talk about utilities. And finally I will give an example in Python language of principal component analysis. So principal component analysis is also known as exploratory factor analysis. It is an unsupervised machine learning algorithm. Factor analysis combines variables that are highly correlated with each other. Principal component analysis is a linear combination of variables. Principal component or a factor can be seen as hidden variable that affects several observed variables. Factor analysis identify if these correlated variables can be described by a factor. Solution of principal component analysis is either by one of these four methods. One is solution using singular value decomposition of data matrix. So here the terms are singular vector or eigenvector, then there are loading scores, and then there is a singular value. Second option is eigen decomposition of the covariance matrix. Third is Nepal's algorithm. And the fourth is eigenvalue approximation via power iteration. Number of principal components are either number of variables or the number of samples, whichever is lower. We can use scree plot as a percentage of variance the principal components account for. So it is graphical representation of variance explained. The first principal component explains the greatest amount of variance in the original features, whereas the second component is orthogonal to the first. These are the steps of principal component analysis using covariance matrix. First of all, we calculate mean of all the variables. Then we make covariance matrix after scaling the variables. Then we calculate eigenvalue of the covariance matrix using this equation. Then we calculate eigenvectors using these equations. Then we calculate unit eigenvector using this, and then we calculate principal components using this equation. Then assumptions and limitations of principal component analysis. Principal component analysis assumes that the variables are correlated with each other. It also assumes linear relationship between features. It also assumes normal distribution of the features. There are certain limitations. One is that principal component analysis is sensitive to scale of features, and it is not robust against outliers. Then utilities of principal component analysis. As we have seen, it is a method of dimensionality reduction. It is also exploratory data analysis. We can compress the information using principal component analysis, and we can denoise the data using principal component analysis. So let us see an example in Python language. These are the libraries. Pandas is for data frame manipulation. NumPy is for array and mathematics. Then there is a data set, the breast cancer data set, which we will use. Then we will standardize the input variables using standard scalar of pre-processing function of sklearn library. Then we will do the principal component analysis, and this is a library for graphical representation. So first of all, we load the breast cancer data and we make a data frame. We will only use the independent variables here. So we will use the x variables and we will ignore the y variable here because principal component analysis is unsupervised algorithm. So this is the data of input variables, and dimension is there are 30 such input independent variables. So this is the dimension. There are total 569 observations and there are 30 variables. Then we standardize the input variables using this code. Then we do principal component analysis and we then produce the components. So these are the reduced components. We have extracted only the two components out of total 30 input variables. So we have extracted first and second component, and this is the graphical representation of our data on the basis of first and second component, and we have colored according to the y variable here. So we can see that there is a good separation between the two groups using first two components itself rather than using all of the 30 input variables. So this is the code for obtaining the loadings, and the shape of the loading is there are two factors and there were 30 input variables. So this is the shape of loading. This is all for today. Thank you very much.